Hi, welcome to our channel and to the Power of 5 Studios. So today, we will discuss about the role of pharmacists in pharmacogenomics. Before we start, what is pharmacogenomics? Pharmacogenomics is the study of how genes affect a person's response to drugs. This field combines pharmacology and genomics to develop effective, safe medications and doses that will be tailored to a person's genetic makeup. Many drugs that are currently available are one size fits all, but they don't work the same for everyone. It can be difficult to predict who will benefit from medication, who will not respond at all, and who will experience negative side effects. So, the pharmacogenomics application can help healthcare providers to decide the most appropriate treatment for each individual by assessing the patient's response towards drug from the genetic information. So everyone, do you know what are the roles of pharmacists in pharmacogenomics? The role of pharmacists can actually be divided into many settings such as oncology, research, drug development, community, drug optimization, and also as prescribing guidance. So now, let's look in deep about the pharmacist's role in each setting. Role of pharmacists in pharmacogenomics is important within the oncology setting. As in cancer treatment, genetic testing can pinpoint the patients who will benefit from certain drug therapies. For example, a woman with breast cancer can be diagnosed by determining her tumor's genetic signature. If the patient tests positive for human epidermal growth factor receptor 2, she can be given trastuzumab, which suppresses the excess receptors. Secondly, pharmacists are also involved from beginning to the end of a research involving pharmacogenomics to study specific diseases where drug therapy is an integral component of a disease management. Single gene polymorphisms greatly influences response of a drug on the other drug. For example, the influence of thiopurine methyltransferase polymorphism on azathioprine-induced myelosuppression. Pharmacists are an expert in pharmacotherapy together with pharmacokinetic and pharmacodynamic components of a clinically prescribed drug. Hence, the pharmacist must be seen as integral part in construction of comprehensive pathways for better treatment outcomes involving pharmacogenomics. Pharmacogenomics become embedded into the drug development process that will lead to the development of genetic tests to accompany an increasing number of new drugs. During prescribing process, currently only very few number of specialized pharmacists are involved. As experts in drug interactions, pharmacists are trained to advise physicians on suitable genotyping tests, drug-gene interactions, and alerting the physician when a medication is not suitable for a patient. For example, HLA-B5701 is a genetic risk factor for abacavir hypersensitivity. Thus, the pre-prescription pharmacogenetic testing of this gene is needed. Based on the information in pharmacogenetics, pharmacists need to relay the facts such as a patient's lacking or having extra drug metabolizing enzymes. For example, clopidogrel is a prodrug that requires CYP2C19 in order to become an active metabolite. Patients who are considered a CYP2C19 poor metabolizer show reduced ability to convert clopidogrel into its active metabolite, resulting in a diminished antiplatelet effect. In a community pharmacy, pharmacists can screen for patients who might benefit from testing, such as those who have been switched from one antidepressant to another more than once, or a patient on several cardiac medications. A patient can provide a DNA sample via buccal swab under the supervision of pharmacists. Then, the sample is shipped to the lab in the testing kit box. Once the report has been released from the lab, the patient meets with the pharmacist to review the results. Patient receives a copy of the report with the pharmacist's recommendation about changes in medication and must consult with physician. Pharmacogenomics is a developing research field that is still in its infancy. Several of the following barriers will have to be overcome before many pharmacogenomics benefits can be realized. The first one is complexity of finding gene variations that affect drug response. Single nucleotide polymorphisms, or SNPs, occur every 100 to 300 bases along the 3 billion base human genome. Therefore, it is hard to analyze. Since many genes are likely to influence responses, obtaining the big picture on the impact of gene variations is highly time-consuming and complicated. The second one is limited drug alternatives, where only 1 or 2 approved drugs may be available for treatment of a particular condition. Lastly, it can also cause disincentives for drug companies to make multiple pharmacogenomic products, as it only serves for a small portion of a population. In conclusion, pharmacists are important in education, design, research, recommendation, and identification in pharmacogenomics. As our profession takes on more clinical roles, we have a responsibility to be knowledgeable and reliable medication resource. That's all from us. Thanks for watching.